Welcome everybody. I'm going to be talking about Graham's law under study of gases, but I'm going to be explaining Graham's law separate from the other gas laws. So for this one, it is broad, like not actually broad, but compared to other gas calculation, it is broad compared to the other. So Graham's law definition states that the rate of diffusion of gas is inversely proportional to the square root of a density at constant temperature and pressure. It says the rates of diffusion or effusion of gases is inversely proportional to the square root of its density. Now, this is the mathematical terms. Now let's go. Since this is a proportionality sign, we can make it to be an equal to sign. So R will be equal to K times 1 over square root of the density. So rates will be equal to K over root density. So let's make K to be a formula. We have R root density is equal to K. So from here we could say that since it is a constant, so we could say that R1 root D1 is equal to R2 root D2. It's also equal to R3 root D3 Rn root Dn, and so on, going to infinity. Okay, so now let's take these two parts for the R1 and R2 comparison. We have R1 root D1 is equal to R2 root D2. And let's take the R to one side and the D to the other side. So let's divide both sides by R2. So we have R1 root D1 over R2 will be equal to root D2, because R2 cancels R2. And let's take root D1 to this other side. So dividing both sides by root D1. Then we have root D1. So we have here cancelling. So we have R1 over root R1 over R2 will be equal to root D2 over root D1. Now, from source in mathematics, if you did solve the mathematics in further mathematics, you will know that once you have root at the top over root at the bottom, you take all of them inside the square root and use 1. What am I trying to say? I'm trying to tell you that if we have R1 over R2, since there are two, both of them are in root, you can take it as root D2 over D1, everything in root. Now this is what I'm trying to say. So from here, we could also say R1 over R2 is equal to root M2 over M1. Now, in solving Graham's law of diffusion, you are either giving your questions in vapor density or given in relative molecular mass of a particular gas. Okay, let's continue. Now this is what we have. It is either R1 over R2 is equal to root D2 over D1, or R1 over R2 is equal to root M2 over M1. Any of them, depending on the type of question you are given or the parameters you got out from the questions. Okay, so now let's continue. Now this is formula 1. Then from here to here, this is 2. Now, once you hear the word rate, if you hear the word rate, it means per time. If you say the rate of volume, it means volume per time. So they say rate of the volume of a gas. Rate of volume is V over T, volume per time. So now, if we were to replace this, or to replace this rate with volume over T, and this one as volume over T. We'll be substituting a new equation in this equation. So what do we do? Now this first rate, we have it to be, let's say V1, arrow 1 is V1 over T1, and for this arrow 2 is V2 over T2. So I would like us to continue from, we had arrow 1 root D1 is equal to arrow 2 root D2. It's the same thing. So taking this here, you go back to, so let's leave it here. So now let's replace arrow 1 with this, then arrow 2 with this. So let's place the value. Anyway, you see arrow 1, you put this value. So we have V1 over T1 root D1 is equal to, arrow 2 is V2 over T2, so V2 over T2 root D2. Now this is another equation entirely from this. So now let's make this equation looks matured. Let's make it look matured. And let's take density to one side, then the volume and temperature to the other side. So what do we do? We can cross multiply. Take this one here, take this one here. So we have this equation 2. So we have this multiplied, so we have V1 T2 root D1 is equal to this multiplied this. We have V2 T1 root D2. So let's take this part to this place and this square root, this density to this other side. So by dividing both sides by V1 V2 T1, then divided by root D1. Or let's not make it confusing. Let's use here. Divide both sides by V2 T1. Divide here by V2 T1. So this will cancel out. So we will be left with V1 T2 root D1 over V2 T1 is equal to root D2. And this is what we have from here, because everything cancels out, so we're left with D2. So let's take this square root here, root D1 to the other side. So we are dividing both sides by D1, that's where D1. So this cancels this. So we have V1 over V1 T2 over V2 T1 is equal to root D2 over D1. I told you once we have square roots, we take one square root, then put everything in the square root. So now this is equation 3 on Graham's law of diffusion. Now note these three formulas now. Then and in a question where they tell you that at equal temperature, like at different volume but at the same temperature, meaning T1 is equal to T2, you will have another equation to be V1 over V2 is equal to root D2 over D1. This is equation 4. And another question comes, they change the temperature, they have the first temperature and they increase the temperature to another value, a higher degree Celsius, but at a constant volume, meaning the V1 is equal to the V2. So since they are equal, they will cancel out. So we left with T2 over T1 is equal to root D2 over D1. Okay, as well, since T2 over T1 is equal to this it will still be equal to R2 over R1. Yeah, sorry, R1 over R2. R1 over R2. So from here we can do some relation that T2 over T1 is equal to R1 over R2. R1 over R2. Now these are all equations under Graham's law. So if you know all these equations, jot anything down in your book. Any question under Graham's law of diffusion, you can peel everyone and peel any question you see in your exam hall. Now let's solve question 1. Now I'm going to be writing down the parameters so you know how to solve questions under Graham's law. Okay, so now first question, if 280 cm cube. So now the first parameter we have V1 to be 280 cm cube of hydrogen gas diffused in 40 seconds. In 40 seconds. So T1 is equal to 40 sec. Full stop. How long will it take for 70 cm cube? So we have V2 is equal to 490 cm cube, sorry, of a gas X. So the gas is an unknown gas. Of a gas S, vapor density of 25. So the density 1 is 25. Sorry, density 2 is 25. So the relative molecular mass of hydrogen is 2 grams per mole. So now what are you asking to find? They said how long will it take? How long will it take? So T2 is unknown. We don't know what T2 is, so they are asking us what T2 would be. Now in all the equation I gave, I gave you that R1 over R2 is equal to root D2 over D1. You can, anywhere you see D2 over D1, you can replace it with root M2 over M1. So the other one I gave V1 T2 over V2 T1 is equal to root D2 over D1. You can replace it with root M2 over M1. Regarding the parameters we are given. But now look at this question. They give us the density of the unknown gas. They give us the rate in density and the rate of hydrogen in relative molecular mass. So now they have different units. So you have to convert from density to molar mass or from molar mass to density. Whichever one you choose is the right choice. So now these are the parameters. So now how do we go about this? So among the formulas I gave, which of the formulas suits? You can use 5 seconds to think from the parameters given. But I think the right formula to use is V1 T2 over V2 T1 is equal to root either M2 over M1 or D2 over D1. So let's use M2 over M1. M2 over M1. So let's place in our values. What is V1? 280 times T2. What is T2? T2 is unknown. Over V2. V2 is 490 times T1. Times T1 40 seconds is equal to root M2. What is our M2 given? Our M2 was given in density. So how do you convert density to molar mass? Molar mass, relative molecular mass. Relative molecular mass is equal to 2 times the vapor density. Vapor density. Relative molecular mass is 2 times vapor density. So to find relative molecular mass of the gas, the unknown gas, we have will be equal to 2 times 25, which is 50 gram per mole. Gram per mole is the unit of molar mass. So now let's replace it. We have our M2 to be 50 over the electric molar mass of hydrogen is 2. So now with this, we are almost done on solving this question. So what do we do from here? We can cancel that. We have 1, we have 0, go with 0. We have 2, 4, 2 we go. We have it here before, sorry, 4 we go, 4 here 1. Then 4 here will be 7, right? 7 here 1, 7, 7. So I'm left with T2 over 70 is equal to 50 divided by 2 is 25, so we are left with root 25. So T2 cannot be black, so it will be equal to 70 times root 25 is 5, so our answer will be 70 times 5, which is 350 seconds. So that is the answer to this question. Alright, so now let's go to question 2. This is question 2, the relative rate of diffusion of a gas as compared with oxygen. So the gas, so R1 is unknown. Relative of a gas is unknown as compared with oxygen. R2 is O2. So comparing O2 of a gas is 2:1. So we have it to be 2:1. So okay, let's continue. Calculate the relative molecular mass of the gas. So how do we do it? First of all, we are talking about rates and the molar mass. The molar mass of M1, let's say X, let's say T of X, then M2 will be equal to oxygen. Alright, so now since we are relating rate to molar mass, it is the first formula given, which is from the law given, that the rate of diffusion of gas or effusion of a gas is equal to the square root of d2 over d1 is equal to root m2 over m1. So R1 was given, they said the relative rate of diffusion of a gas as compared with oxygen is 2:1. So R1 is 2:1 is equal to square root of M2. Our M2 be, our M2 is oxygen. Oxygen is 16, so oxygen gas is 16 times 2. So you have 32 over the unknown gas, let's use X. So now, how do we continue? So we have 2:1. 2:1 is same as 2 over 1 is equal to root 32 over X. So now, how do we find the value of X? There's nothing we can do here. 32 does not have a standard value. We're going to take the square root. So you square both sides. So we can eliminate the square root. So 2 here, we cancel this 2. We cancel the square root. Because the square cancels the square root. The square root is, I want to say square root of X is same as x to the power 1 over 2. So squaring it, these are indices. If we take the up indices, we are multiplying this with this. So we have x will go to 1 over 2 times 2. So 2 cancels 2 are left with x. So 2 square will give us 4, 1 square will give us 1, be equal to 32 over x. So first multiply, we have 4x, 4 times x will be equal to 32 times 1. So we have to divide by 4. We have x to be equal to 2 here, 2 here, 2, 2 here, 16, 2 here, 1, 2 here, 8. So we have x to be equal to 8. So now that's the answer to this question 2. Okay, we're going to be seeing some few other calculations, other Graham's law. Then the question 3: if 30 cm cube of oxygen V1 is equal to 30 cm cube oxygen definitely through a cross spot in 7 seconds. So T1 is equal to 7 seconds. How long will it take? So the T2, how long will it take? So T2 is unknown, which is the time. When you say how long, means the time taken. Will it take 60 cm cube? So the V2 is 60 cm cube, which is for chlorine. To diffuse through the same port. If the flow pressure of O2 and Cl2, which is oxygen and chlorine, are 16 and 36 respectively, so the density 1 is equal to 16, then D2 is equal to 36. So what equation are we going to use? What formula are we going to use to solve these parameters? So which of these will work? I believe this will work. V1 T2 over V2 T1 is equal to root D2 over D1. So now let's go. What is V1? V1 is 30 times T2. T2 is unknown. V2 is 60 times T1 is 7 is equal to root is equal to root. What is D2? D2 is 36 over D1 is 16. 16. So now let's cancel that. 30 here will give us 1, 30 here will give us 2. So we're left with 32 over 2 times 7 will give us 14. We're left with 36 over 16. So now let's take the square root simultaneously. So square root of 36 will give us 6 over square root of 16 will give us 4. We are left with 6 over 4. So can we do any cancellation here? So we have 2 here, 3, 2 here, 2. Then let's just multiply immediately. So we are left with T2 is equal to 14 times 3 over 2. 2 here 1, 2 here 7. So 7 times 3 gives us 21. So the answer is 21 seconds. So question 4. They said, if the rate of diffusion of oxygen is taken as 1, what would be the rate of diffusion of methane, which the molecular mass is 16? Okay, let's go. If the rate of diffusion of oxygen is taken as 1, so R1 is equal to 1. What would be the rate of diffusion of R2? Unknown. They said what will be the rate, so it is unknown. So by dealing on molecular mass, so M1 of oxygen is 36, then M2 was given as 16. So now I gave us the formula that R1 over R2 is equal to root M2 over M1. So R1 over R2, so R1 was given as 1 over 16 is equal to root M2 was 16 over 36. So the rate is unknown. Sorry, which is unknown. R2, we are left with R2. So what do we do? R1 over R2 will give us square root of 16 will give us 4. Square root of 36 is 6. So 2 here 1, 2 here 2, 2 here 3. So we multiply, or if we want to multiply, the same thing as if we have to take this upside down, we'll take this upside down because it is an equal. So anything you have to do to here, we'll do it same thing here. So we're taking this one upside down, so we are left with R2
over 1. So take some time down, have 3 over 2. So arrow 2 divided by 1 give us arrow 2, which is equal to 3 divided by 2 give us 1.5. So the rate is 1.5. Now this is the solution to question 4. Now we are done with calculation on the introduction to Graham's law of diffusion. Now more questions will be dropped after this video. Okay, so thank you for watching.